Okay, so this video deals with other 3D shapes that we may come across, and the first one we're going to look at is a cylinder. So the first thing we're going to look for here is the volume of the cylinder, and we're going to take pi as 3.14. So if we go to our log tables on page 10, we'll see here the cylinder, and we'll see V equals pi r squared h, and that is the formula for the volume of a cylinder. So I'm going to write that down in full. So V equals pi r squared h. I'm looking for the volume. Pi I'm putting in is 3.14. The radius, of course, goes from the center to the circumference, which is given to me here. So 7, don't forget squared, follow the formula exactly. And the height of the cylinder is obviously here, which is 12. So subbing that in, remember, whatever you sub in, keep brackets around it. That way we can type it in as we see it on the calculator. And that's exactly what I'm going to do now. I'm going to do bracket 3.14, bracket 7 in brackets, don't forget to square it, and then in brackets 12, and I'll get my answer. And we'll give it to 2 decimal places. So it's coming up to 2 decimal places exactly. So we at 1846. So the volume is 1846.32. And of course, it's a 3D shape, centimeters cubed. Now we're going to take a look at another cylinder here, okay? And this one, we're going to ask for it in terms of pi. So as before, get your formula written out in full from your log tables. And now let's fill it in. Of course, we can't fill anything in for the V. We're looking for that. Pi this time is in terms of pi, which means we're going to leave it as pi on our calculators. The radius, now watch out in this one. We aren't clearly given the radius because the radius, of course, would be from the very center of that circle at the end to the circumference. What we are given, though, is that full width. In other words, we're given the diameter of that circle. So in order to get the radius, which is what I need for the formula, I'm going to have to half it. So half the 12, and I get 6. Don't forget to square it. And then the height, well, it is 80, although it's on its side. If it was turned upright, it would be 80 of a height. So that's what we're putting in for the h. And then on our calculators, we're putting in the pi button on the calculator, which of course is shift, and then press this button down here. And then bracket 6 squared, and then bracket 80. And the answer will come up in terms of pi on the calculator. So putting it down then, the volume is 2880 pi. Don't forget your units, centimeters cubed again. Okay, so this time we're going to look at a sphere, and again we're going to look for the volume of this sphere. So we're going to go to our log tables again on page 10, and here's the sphere down here, and obviously the formula for the volume is V equals 4/3 pi r cubed. So I'm going to write that down for myself straight away. V equals 4/3 pi r cubed. And let's fill it in. We're going to take pi this time to be 22/7, okay? So we're looking for the volume. So filling in 4/3 stays as 4/3. Instead of pi, we're subbing in 22/7. And the radius is, of course, going from the center to the outside, or the circumference. So we're putting in 11. And don't forget, this time, watch very carefully, follow that formula exactly. We've got a cubed there. So now we're going to fill that in on the calculator. And I'm going to put my fraction button up first, this one here. I'll put 4 on the top, and then 3, and then our bracket. And then I'm going to put the fraction button again, 22/7, and then close the bracket, open the bracket again, 11. And then for the power of 3, I'm going to press this button here, x to the power. And that will allow me to put the 3 in there. So there I have it exactly as I have it written. Remember, whatever you sub in, keep brackets around it. And I'm getting 5,577.52. We'll do 2 decimal places, so look at the number after the 2, which is 3, which will mean we'll leave it. It doesn't make it bump up, which will mean we will leave it as 0.52. So the answer is 5577.52 and centimeters cubed. So with a question like this, what we have here is half a sphere. So what we're going to want to do is get the volume of a sphere up, which is 4/3 pi r cubed. But since we only want half of that, I'm going to multiply that by a half, okay? You just want a half of the volume because it is half of a sphere. So we'll get the volume of the sphere and then we'll half it by multiplying by a half. So in this case, we have 4/3. This time, let's take pi as 3.14. So putting in 3.14 as pi, the radius quite clearly is given to us here as 5 cubed times a half. So I'm going to put that in on my calculator, and I have 4/3 bracket 3.14, close the bracket, 5 cubed, come down to the side, times a half. And the answer is 261.66. We'll do 2 decimal places again, so we look at the next number, which is also a 6, which will mean it'll bump up the 6 before it. So we'll end up with V equals 261.67 centimeters cubed. And the next shape I'm going to look at is a cone. And again, we're going to find the volume, and we're going to take it in terms of pi this time. All right, so it can be asked in the questions, it can be asked a few different ways. Pi is 3.14, maybe pi is 22/7, or in this case, if they ask for it in terms of pi. So again, we're going to go to our log tables on page 10, and we're going to see where is the volume for a cone. And here we are here. So V equals 1/3 pi r squared h. Let's take that down in full and be sure that you get it down correctly. And now we're going to fill it in. So V equals 1/3, we're going to leave pi as pi, and of course the radius is down here in the circular part at the base, which is 5, so 5 squared, don't forget the squared, follow that formula exactly, and the height of the cone is of course 12, so subbing it in brackets, and then on the calculator we'll do that, so 1/3, and then shift pi. Oops, it's gone down below. Let me come up here and then do that again. Pi, now I have it in the right place. Bracket 5, close the brackets, squared, and then bracket 12. Okay, so now I have it written exactly as my working out, and press equals. And the answer is 100 pi, and that's the way I want it because I want the answer in terms of pi, but of course it's volume, so it is centimeters cubed. Right, now let's look at some questions where we're given the volume and we're looking for some lengths. So in this question, we're going to revisit this cylinder, but this time we're being told that the volume is 2,769.48 centimeters cubed, and we need to find the height. So the first thing you're going to do, as always, is as soon as you realize we're talking about the volume of the cylinder, put down the formula in full. So pi r squared h, okay? And again, that's from the log tables. So this time we know what the V or the volume is. So we're going to sub in 2769.48 in for the volume. Pi, we're told in the question to take is 3.14, so make sure you fill that in as well. The radius we can see here is 7, so 7 squared, but the height we don't know, so we'll leave it as h. Now, let's see, I have 2769.48. You can go ahead and evaluate this bit. So 3.14 times 7 squared works out to be 153.86 times h. Okay, so now to get the h on its own, we'll divide by the 153.86 on the right hand side. That will get rid of it to give me the h on its own, which is obviously what I want. I'm looking for the height. And of course, if I divide by 153.86 on the right, I've got to divide by 153.86 on the left. So when I do that, I get my answer, which works out to be 18 centimeters. Okay, so let's try this question. This time we're given the sphere, we're told pi is 22/7, we're given the volume of the sphere, and we're asked to find the radius. So immediately once you identify we're talking about the volume and a sphere shape, get that formula written down in full from your log tables. So there we go. Okay, so this time I can fill in for the V, which is 38808. equals 4/3. Pi is 22 over 7. And of course, r we don't know, so we may leave that as r cubed. Now, rather than evaluate this, because I'm probably going to get something really nasty, what I'm just going to do, because I want to get rid of it, okay, and it's all being multiplied to the r cubed, I'm going to go ahead straight away and I'm going to divide by it. I'm going to divide the right hand side by 4/3 times 22 over 7. That will get rid of all of that and leave me with the r cubed on this side, which is what I want. And of course, if I divide that side by that, I'm going to have to divide the left hand side by 4/3 times 22 over 7. Okay, so I do that on my calculator. So put up the fraction button, put 38808 on the top, come down and then press the fraction button again, and we're going to put 4/3, come to the side, press the bracket, press the fraction button again, 22 over 7, come to the side, close the bracket. So there we go, there's exactly what I have written down there. Press equals and I get 9261. And now to get from r cubed to r, we must undo the cube, in other words, cubed root 9261. So get your calculator, and to get cubed root, we're going to access it here above the square root button. You can see there's a cubed root button, so shift, press that, and the cubed root button should come up, 9261, press equals, and the answer is 21. So the radius is 21 centimeters. Okay, so try this question then with the cone. If the volume is 256 pi, find the radius. So here is the diagram. We have our answer in terms of pi, obviously. Writing down the volume of the cone, of course, that's what you're going to do first. Take down the formula in full. So 1/3 pi r squared h. Let's fill in what we know. Well, the volume is 256 pi. 1/3 stays 1/3. Pi will stay pi because we know it's in terms of pi. The answer is in terms of pi. And then r squared, of course, we don't know what r is, so you may leave that as r squared. And the height, we can fill in the height. We can clearly see it is 12 from the diagram. So I'm going to want to get r squared on its own before I can get r on its own. So basically, if I want to get r squared on its own, I'm going to want to get rid of the third, the pi, and the 12. And all of those things are being multiplied there on the right-hand side. So what I'm going to do is I'm going to divide by all those things. Then 1/3 pi and 12. Okay, all of those things I want to get rid of. And that will get rid of that, that will get rid of that, and that will get rid of that, which is what I want, and to be left with just the r squared on its own. Of course, if I divide the right-hand side by 1/3 pi and 12, I'm going to want to divide the left-hand side by 1/3 pi and 12. Okay, so this is what I'm going to do on the calculator. So put your fraction button up, put 256 and put the pi button, come down underneath, put your fraction again for the third, 1 on the top, 3 on the bottom, come to the side, we want pi again, and then in brackets we want 12. So exactly as I have it here, I'm going to type it in, press equals, and I get 64. So if r squared is 64, the only way to undo the square is of course to square root. So therefore r is equal to 8 centimeters. Okay, now let's take a look if they ask about surface area. All right, so let's take a look in our log table. So if you go to your log tables, page 10, there we can see our formula for cylinder. We can see that the volume's pi r squared, and A for area is 2 pi r h. Now be very careful, read up here, this is very important. In the following, A represents the curved surface area. Okay, that's not the total surface area, it's just the curved part, all right? So I'll talk about that in a bit more detail. V represents the volume, but A is just the curved surface area. So let's just take this down and then I'll talk about it in more detail. So A equals 2 pi r h is the curved surface area. So with this cylinder, the curved surface area is just the curved surface. Okay, so this explains it a little bit clearer for us what exactly the curved surface of a cylinder is. Okay, the curved surface is just the surface that goes around the cylinder like this. And if you were to open it out, it would make a rectangular shape. Okay, and of course the length of that rectangular shape would be the length that goes around the circle. And of course, the length that goes around a circle is circumference. So it's no surprise that the length of this rectangle is the very same formula as the circumference of a circle, 2 pi r. So that's the length of the rectangle, and the width of the rectangle is the same as the height of the cylinder. Okay, so the 2 pi r h is just getting you this part of the surface of the cylinder. It is not including the circle that's on the top and the bottom of the cylinder. So you want to be very careful in a question like this. Are they just looking for the curved surface area, or are they looking for the total surface area? Because if they're looking for the total surface area, you're going to need to include the top surface, which is a circle, and the bottom surface, which is also a circle. And the area for those, of course, is pi r squared and pi r squared. So back to the question. So what we're going to do with this, we're going to get the total surface area. So first of all, obviously we've got to get the curved surface area, and then we'll add on the circles as I explained, the top and the bottom. So we have A equals 2 pi. In this question we're going to sub in 3.14. The radius is 7 and the height is 12. And so for the curved surface, 2 bracket 3.14, 7 in brackets and 12 in brackets, we are getting 527.52. So that is the curved surface area, and if that's all you were asked for, you'd be done. But the total surface area is going to be 527.52, add on pi r squared, which of course is the top circle, and another pi r squared, which of course But if, of course, you're asked for the total surface area, then you've got to consider the top, which of course is a circle. So pi r squared is the area of a circle. So filling that in, 3.14 times 7 squared, we are getting 153.86. Of course, the side is all around the side, which is the curved surface area, and that we have here, so 527.52. And of course the base is a circle as well, so pi r squared, so we have 3.14 times 7 squared again, so 153.86. Now again, you don't need to do it out as long as this, adding them all up together. You can spot straight away that you have 2 circles, so you can double that immediately and then just add on the curved surface area. Whatever helps you speed up, by all means use it, but just showing it out clearly step by step just allows you to see exactly where I'm getting everything from. So let's add up these, 153.86, and we are getting 835.24 as our total surface area. And don't forget, of course, it's area. The units are going to be centimeters squared. Okay, let's consider the surface area of a sphere. So if we look in our log tables on page 10 and we go to our sphere, we can see that our formula for area is 4 pi r squared. In other words, where A represents the curved surface area, remember that, that is the formula for pi r squared. Now, what's interesting to note with the sphere is, of course, the only surface area that a sphere has is the curved surface area. So if I've been asked for the total surface area, there's no other surfaces that I need to add on. The total surface area of a sphere is the curved surface area. So let's write this out for ourselves. A equals 4 pi r squared, and filling it in pi we're going to put as 22 over 7. The radius, of course, is 11, and then of course squared. So let's do this on our calculators. 4 bracket 22 over 7, close the brackets, 11 and squared, oops, equals And let's do to 2 decimal places, 0.14. Look at the 2. The 2 that comes after tells us what to do. And in this case, it tells us to leave it as it is. It doesn't make it bump up. So my final answer to 2 decimal places for the total surface area of this sphere is 1521.14 centimeters squared. Now, what about this hemisphere? Okay, if you're asked for the total surface area of the hemisphere, what are we talking about? Well, first of all, we're going to have to consider the curved surface area. And of course, our formula for the curved surface area of a sphere, a full sphere, mind you, is 4 pi r squared. Now, we don't have a full sphere here, so straight away you're going to want to half this. All right, that will give us the curved surface area of the hemisphere. Okay, so we have the curved surface area of a full sphere, and times by a half gets us half of it. Now, the other thing that we must consider with this, though, is this shape does not just consist of the curved surface. There is also a surface on the top, and that surface on the top is a flat circle. So if I want the total surface area of this hemisphere, I'm going to have to add that on. Okay, let's do this first. So we have A equals pi, we're going to take as 3.14. So 4 bracket 3.14. The radius, of course, is 5. And we're going to times the whole thing by a half. Okay, so on the calculator, I have 4 bracket 3.14. I have 5 squared times, and put in my half, because I want half of all of this. So I'm getting 157 centimeters squared. That, of course, is the curved surface area. And now for the total surface area. The top is, of course, a circle, pi r squared. So 3.14 times 5 squared, which of course is 14 times 5 squared equals 78.5. And the sides, of course, is just the curved surface. So we're adding on 157 there. And the final answer then for my total surface area of this hemisphere, 235.5 centimeters squared. And finally, we're going to get the total surface area of this cone. So again, let's take a look in our formula, our log table, should I say, the cone. We have the A is equal to pi or L. Okay, now A, remember, is of course the curved surface area. The L, by the way, is this diagonal length. All right. Now, immediately we spot that we're not given this diagonal length. So the first thing I'm going to have to do is figure out what that diagonal length is. And so with a cone, what you're able to pull out as a shape inside is, of course, a right angle triangle, where that is 5 and that is 12. And we're looking for this L, this diagonal length here. And of course, the thing that we can use with a right angle triangle when looking for a side is Pythagoras. And so Pythagoras is c squared is equal to a squared plus b squared, and c is always the hypotenuse, isn't it? So the hypotenuse in this case is the L. So L squared is equal to, fill these two in, it doesn't matter which way around these two go, it's just hugely important that you put the hypotenuse in for the c. So I'll put in 5 squared plus 12 squared, and of course that gives me 25 plus 144. So L squared is equal to 169. And now to get L from L squared to just L on its own, to undo the square, of course, we square root. So square root of 169 is 13. So that means that side length is 13. Okay, so now let's get the total surface area. So the curved surface area, that formula is, of course, pi or L. All right, so let's consider that first, but be mindful with a cone, The curved surface is just the surface around the sides. On the base of a cone, we have a flat surface, and that, of course, is a circle. So if we want the total surface area of a cone, it's going to be the curved surface, add on the flat surface of the circle for the base. Okay, so that's really important. Let's do the curved surface area first. So A equals, we want it in terms of pi, so leave pi as pi. And then the radius is 5. The diagonal length is 13. So I'm left with, and again, you can type this into the calculator, all right? Shift, put in your pi button, bracket 5, bracket 13, and the answer is 65 pi. So 65 pi is the curved surface area. For the total surface area, we want the sides, which of course is this, 65 pi, and of course the base, which is pi r squared, which is leaving pi as pi. The radius is 5, that is 25 pi. So now add these two together, and we get, you can do this on the calculator if you're a little bit unsure. All you're going to do is add the numbers. The pi will just stay, but if you're unsure, 65 pi plus 25 pi is, of course, 90 pi. And its area, so centimeters squared. Okay, so we're going to go through a few questions now where we have more complicated questions involving these other 3D shapes. Press pause if you want to give this one a go yourselves first, or keep watching as I go through the full solution of this one now. So, first thing it asks for is the volume of the cone in terms of pi. So here we have, as it explains here in the question, we have a cylinder with a cone on top, or if you want to consider it as two cylinders and a cone on top, representing the model of a rocket ship. Okay, so the information is written on the diagram. So let's jump straight into part I, which is asking about the volume of a cone. So immediately, once you realize what the question is about and what the shape is, let's get the formula written down in full. So going to your log tables, of course, volume of a cone is going to be V equals 1/3 pi r squared h. Let's write that down in full for ourselves. Okay, so we don't know what the volume is, of course, that's what we're looking for. 1/3, we want it in terms of pi, so let's keep pi as pi. And then we want the radius of that cone. Now, the radius of the cone isn't given to us clearly here, but if you look down at the bottom of the shape, we do have the full width of the shape, which means that 20 is the full diameter, which implies then that the radius is going to be 10. So here we go, 10 squared, and the height of the cone, well, we do have that quite clearly there, is 24. Okay, so let's do that on the calculators then. So putting in the fraction 1/3, and then of course the pi button, bracket 10, bracket squared, and of course in brackets 24, equals 800 pi, and that's the way we want our answer in terms of pi. Centimeters cubed, of course, don't forget your units. Right, now part 2 asks us to find the height of the cylinder if the volume of the cylinder is 4 times the volume of the cone. Okay, well, if the cone is 800 pi, times that by 4, and you're going to get 3,200 pi centimeters cubed. So that is the volume of the cylinder. So we then need to find the height. So since we're talking about the volume of a cylinder, go to your log tables, of course, go to page 10, go to cylinder, go to volume, V equals pi r squared h, get that written out in full. And let's see what we can fill in. Well, we now know what the volume of the cylinder is because it's 4 times the volume of the cone. So we can fill in 3,200 pi for the V. pi, of course, is pi. The radius of the cylinder, well, the radius of the cylinder is the same as the radius of the cone, so that is 10 squared. And of course, we'll have to leave h as h because we don't know what that is. So we want to get h on its own, so that means we want to get rid of the pi and the 10 squared. So in order to do that, I'm going to divide that side by pi and 10 squared. That will get rid of all of that and leave me with the h on its own, which is what I want. Of course, if I divide the right hand side by pi 10 squared, I'm going to have to divide the left hand side by pi bracket 10 squared. And on the calculator then, of course, I'll do that. Put up the fraction, 3,200 pi on top, and then of course the pi button bracket 10 squared on the bottom. And that leaves me with 32. So 32, what are our units? Centimeters, of course, so 32 centimeters is the height. Okay, let's have a look at part 3 now, which asks find the value of K if the volume of the cylinder of height K is half the volume of the whole solid model. Okay, so I just have that shaded in there. That is the cylinder of height K, okay, that bottom cylinder there. And if that is half the volume of the whole model, then can we work out the value of K? Well, let's consider what the volume of the whole model is. The volume of the whole model, of course, is the volume of the cone, which we know from part I, add on the volume of the large cylinder, if you're considering that whole bottom as the large cylinder. So the volume of a cone, of course, is 800 pi, which we had at part I, and then part II, the height of the cylinder, is 4 times the volume of the cone, so we have that already as 3,200 pi. So the total volume of the whole model is, of course, 4,000 pi. Now, if this bottom cylinder is half that volume, okay, and we want to find the value of K, let's consider the shape that we're looking at, of course, is the volume of a cylinder. So get that formula written down for yourself straight away. Pi r squared h. The volume of this shaded bottom cylinder, we were told, is half the volume of the whole model. So half 4,000 pi. And of course, on the right hand side, we have pi. The radius, of course, is 10, and the height is K. So now to get K on its own, well, evaluating the left hand side a little bit, a half of 4,000 pi is 2,000 pi. And on the right hand side, I want K on its own, obviously. So in order to get K on its own, I'm going to get rid of the pi and the brackets 10 squared. So divide that side by it, and that will get rid of that and give me the K on its own, which is what I want. If I divide the right hand side by that, I have to divide the left hand side by that. And of course, if I do this on the calculator, typing it in exactly like that, I get 20. So 20 therefore is the height of that bottom cylinder, and hence the value of K. Okay, what we're asked for in this question is the volume of this cylindrical metal pipe, and they want the volume of the pipe in centimeters cubed. Okay, so with this kind of a question, what we have, of course, with the pipe is a larger cylinder with a smaller cylinder removed. So that's exactly what we're going to have to fill out here or work out. It's kind of like one of those in-between volumes, if you like. We're going to do the larger cylinder, the full mass of the larger cylinder first, and then, of course, subtract the smaller cylinder. And then that will give us what's left, just the pipe. So, since we're talking about volume of a cylinder, get your formula written down, pi r squared h, and of course here pi r squared h. We're told to take pi as 3.14, but there's one other thing I need to address, and that is the fact that, of course, we have these values in centimeters, but this value for the length or the height of the cylinder in meters. Now, be very careful if they throw something like this in at you, because you cannot put those values in unless they are all the same units. So the first thing you're going to want to do is change that 1 meter to centimeters. And of course, 1 meter is equal to 100 centimeters. Okay, press pause if you want to give this one a go yourselves. Otherwise, watch on and we'll work through it together. So, working this out, I'm going to fill this in. Pi, of course, is 3.14. Now, the radius of that larger pipe is, of course, since 6 is the full width of the larger pipe, then that means that 3 is the radius of the larger pipe. So 3 squared times 100, and then take away, and of course 3.14. The radius of the smaller pipe, of course, the full diameter is 4, which means half that is going to be 2. And the height, of course, is the same, so 100. So we have this subtract this. And if I do that on the calculator, I get 3.14 and then 3 squared times 100 equals 2826 minus 3.14 times 2 squared times 100. And of course, I'm getting 1256. So 2826 minus 1256 works out to be 1570, and of course it is centimeters cubed. Okay, so this is the last question we're going to take a look at. Here we have a sphere of radius 4 centimeters dropped into a cylinder partly filled with water, and when the sphere is completely submerged, the level of the water rises by h centimeters. If the radius of the cylinder is 8 centimeters, find the value of h. So it gives us a little hint here. It says that in the given diagram, the volume of the sphere is equal to the volume of the shaded cylinder of height h. Now, they mightn't always give you this little tip, but it's worth just knowing with questions like this. The minute you are submerging something into water, then however much the shape that it is increased by, if you like, you can see there once it's submerged, this darker blue cylinder is the shape that then is formed once the sphere is submerged. So that means then that the volume of this sphere is equal to the volume of that dark blue cylinder where the height is h. So that means the volume of the sphere is equal to the volume of the cylinder that is, of course, that little cylinder up on the top. So volume of a sphere, get that formula written down for yourself straight away, and that is 4/3 pi r cubed. Volume of a cylinder, of course, is pi r squared h. So filling in, it doesn't say what to take pi as, so my advice is to leave pi as pi on the calculator. So we have 4/3 pi. The radius of the cylinder is quite clearly 4 cubed. Leave pi as pi. The radius, sorry, that's the sphere, is 4 cubed. The cylinder, the radius of the cylinder is quite clearly 8. So that's 8 squared. And the height, of course, is that little height. That's that little cylinder part we're looking at here. So h. And we're looking for h. Well, let's evaluate the left-hand side first, shall we? So on the calculators, let's put in 4/3 pi, and of course bracket 4 cubed, and we're getting now we're getting a long decimal here, so I'm going to leave it in terms of pi. So I'm going to write it like this: 256/3 pi. On the right hand side, I have, of course, pi times 8 squared h. If I want h on its own, I want to get rid of the pi times 8 squared. So that would get rid of that and leave me with just the h, which is what I want. But of course, if I'm dividing the right hand side by that, I'm going to have to divide the left hand side by that as well. So what I'm going to do is get that back up for myself. I have 256/3 pi. And then I'm dividing by, so underneath again, pi bracket 8 squared. And the answer is 4/3. So in terms of centimetres then, it's 4/3 of a centimetre, or you can write it as decimal, 1.333, or 1 1/3.